This beautiful photo is of a rainforest in Madagascar. Look really closely and treat yourself to one of the most difficult games of Where's Waldo in the world. How many species can you see? Just take a second. Now let's listen. Can you hear that? Immediately, the animals that were hidden to the eye can be heard easily. This lush soundscape contains dozens of species of the hundreds that reside there. My name is Shawn Keech. And today we'll be detecting and classifying rainforest fauna from environmental audio using a convolutional neural network. Our data set that we're looking at today contains 24 species. All the names are anonymous though. They basically just give, instead of frog or parrot, just designations like species 1 or species 10. We're going to be using a convolutional neural network to figure out which species is which. Now, you may have heard about convolutional neural networks because they're really, really good at working with pictures. And that's kind of funny because what we're going to do is we're going to turn our audio into something that we can use. This picture over here on the left, if you've ever worked with audio, is a very common way for people to visualize audio. From left to right, it's just time, and up and down is amplitude, how strong the signal is, which is interesting when we're using, say, GarageBand, but it's not very useful for training a neural network. What we'll do is we'll apply a fast Fourier transform. This is one sample of a fast Fourier transform. You can even notice a peak there at the frequency of 4,000 hertz. And another little mountain that starts about 8,000 and kind of ends around 10. Much more useful, but there is a problem with that. Let's take a look at that problem. Wow, this is a 48,000 sample per second audio file. So there's 48,000 of these little lines, and that's just a big cluttered mess. So we're going to do another transform to kind of help us out. Over here to the right kind of gives us an idea what we're going to do. We still have time across the x-axis, and now our frequency is over here. The green pixels that you're seeing are stronger as the power increases. Let's look at that more closely. I've added a black line here and a black line here to give you the frequency band in between which is our species. We're taking these and we're going to feed it into our neural network to help train it. Over time, when we start, it doesn't do very well. There's a lot of problem, there's a lot of error. And as we go through the epochs of training, it gets better and better and better. Around epoch 8, it starts to level out. And our accuracy, luckily for us, goes up and up and up until it levels out between 8 and 12 epochs as well. Here's how it's doing on each individual species. So species 1, we made the prediction that this was the 0th species, and it was 10 of the times. This was species 1, we got those 7 right, and across this diagonal, you can see how many times our network predicts the correct species. Every once in a while, it'll get a little bit of an error, but it's giving us about 95% accuracy, which is pretty great. Our next steps are to enable processing of an audio stream that's live. So you can take a microphone and listen to an environment and tell in real time whether the animals arrive. We'd also like to deploy our model online using a local microphone. My name is Shawn Keech. Thank you for your time.